Okay, let's take a look at this question. Energy. So what do we see here? We see a spring with at first it's being a ball is being placed on top of it, and then it's being pushed down and released. Yeah, it's a springboard. So what type of energy do you think is happening over here? What's the energy conversion when you?
PE is converted to KE plus GPE.
Yeah, very good, right? So the first one that you will fill in is elastic
Potential energy.
Yep.
I put EPE.
Alright, I'm just going to go short form, right? So elastic potential energy convert to
Gravitational.
and
Converted.
yeah, so it's KE
Plus
and GPE. Now how do you know there's KE? Because it's moving. Moving. How do you know there's GPE? Because it's going upwards. Okay? Right, next one. So Sunita observed that the ball always flew over the basket but did not land in the hoop. One way in which Sunita can ensure that the ball will land in the basket. Okay, what can Sunita do? Okay, now what we're going to do is we'll go one by one. Okay, let's start from Eunice. What do you think is the solution over here? What is your solution for her? Yeah, Eunice? What do you put there? Is it very long answer? I never write. Yeah, okay, never mind. Then your turn, Akhil. Okay,
move
Sunita.
the springboard back.
Ah, very good. Okay, so she can move the spring. Now there are several answers here, right?
Many possible. 1,000 possibilities.
Not so many lah. Maybe like 2 or 3, right? So one possibility is she can move the springboard back. Why? Because when she moves it back, which is over here, it will not move. The ball is not going to go over. Okay? Over. So just move it back a bit. Now there's another thing that she can do. Can someone tell me what else can she do?
Oh wait.
There's one more thing.
When she press down the ball, she can go like fully.
Correct. Okay, don't push it down fully. Look at this. Now look at this. Right, she pushed the whole thing maximum. Right, go all the way.
Use less force to push.
Yep, use less force to push it down. So if she does that, then the ball is not going to fly overboard. Okay, good. So next question. So team set up an experiment as shown. So he measured the temperature of the air inside using a data logger. The contents are left in the sun for a few hours. So in container X or on top of container X with a lid with a grass planted. Another one with a lid with no grass planted. What do you think is going to happen to the temperature at container X? Is it going to be higher or lower? Which one higher, which one lower?
X is lower.
X is lower. Very good. Y is going to be higher. So we will go on to the answers. So we have the temperature shown there, right? So X is lower, Y is higher. So in what way does the presence of grass affect the temperature? Let's have Gareth.
Me? Gareth or Jared? You see, you keep saying Gareth.
Gareth. Because TH, see, TH is
Gareth.
right? So it's Gareth.
Jared.
Gareth. Okay, never mind. Gareth. Come.
As the presence of grass increases, the temperature inside, the temperature of the air inside decreases.
Yes, okay, the grass decreases the temperature of the air in the container. Okay, now do you have to explain why in this particular question?
No.
No, because
Describing.
yep, they did not tell you to explain, right? Just describe. Okay, next. So next one. So using the results from Tim's experiment, explain how planting plants on the roof helps in the conservation of energy. Jared, come. Next is yours. How? You can sit down. It's okay. Take a seat.
All B, right?
Yep.
You keep the building cool so the residents don't need to turn on the aircon.
Very good. Okay, excellent. So explain how.
Saving.
Yeah, it saves energy. So the plants is that the plants keeps the building cool and hence residents
You don't use air conditioner.
yeah do not have to switch on
Can't see a
yeah
thing.
wait extend the thing switch on air conditioning or fan which saves energy. Okay. Okay, the plants will keep the building cool and hence residents do not have to switch on air. Okay, so these are all 1 mark questions. 1 mark questions you don't have to
Describe it.
yeah like do like a huge boom explanation. So it's very
Rocket
straightforward.
science.
No rocket science stuff. Okay, it's straightforward.
But
But
there was one in my exam paper, I wrote like 10 lines. I got it wrong. Like 0 marks.
so what did you write?
I read a while. A lot. I need to write on the next page.
Serious? That's too much.
I read the.
Sometimes
Was
don't.
that
But you have to
3-mark question?
you have to write relevant things. Okay, don't write irrelevant things. When you write irrelevant things, that's what happens, right? Okay, next one. So band setup experiment as shown. Now this is a tower, not town. Alright, so A and B same size. Tower A. So tower A obviously has a bigger surface area, whereas tower B does not have such a big surface area. So the time taken for the two towers to reach temperature of 20 degrees Celsius was noted. So they have the temperature. Which one do you think took a shorter time? Let's have Eunice. A, very good, right? So now you have to explain. Now you see, even though it's 1 mark, but they ask you to explain, right? So let's put the answers down. So tower A.
Here is a bigger surface.
Correct, but that is not the final complete answer. So Eunice, how would you explain this? For heat, very good, right? So I'm just going to write the keywords, right? So we want to see things like more exposed or bigger exposed surface area for heat to escape. Okay, you have to go and word it, rephrase it properly. So you rephrase the thing, right? We want to see because tower A is folded in such that it has a bigger or more exposed surface area for the heat to escape, and therefore it will cool down faster.
Tower A, as it is folded,
The way it's folded has more exposed surface area for heat to escape. Hence it cools down faster.
as the
Oops. Okay. Right. So that is the
tower
answer.
A,
Right. I'm writing in point form. You can write in point form as well. Okay. Just take note. You need to have this stuff. Okay. Because here we are doing science, so we want to. I just want to write down the keywords. And we don't waste time or spend too much time waiting to copy down. Okay. And furthermore, I said that all this stuff, we are recording it electronically, so you can reference to them again, right? You can send the link to you can see again. Yep. Right. I'm recording all this down, so if you tell any jokes here, you can listen to it again the next time. Right. Right, so once again, I'm just putting in the keywords only, okay? And now I'm going to go faster because we have too many questions to
the
go.
tower has more exposed surface.
Okay, next one. Next. Okay, so based on the answer in A, so we have a black color figurine here. Why the penguin spend more time standing on ice? How can we tell? The silhouette looks like a penguin. Rather than lying down. Why doesn't it lie down? Why does it just stand on 2 legs?
Oh, because.
Something to do with surface area, right? Odelia,
Oh yeah.
it's your turn.
Because less Surface area touching the cool ice.
Yep. So
I just guessed.
when it's standing, it loses less heat. Right, so there is a smaller surface area exposed to the cold ice, hence it will lose less heat as compared to when it is lying down. Okay? No, don't worry about copying everything. As I mentioned, we will.
How do you even send us something?
It can be done. Okay, don't worry. So the idea is this: when it's standing, okay, I need to understand. So when it's standing, you see the leg surface area very small, no? Small surface area. Alright, so it loses less heat. Small surface area exposed to the cold ice, hence it will lose less heat compared to when it is lying down. When it's lying down, the whole body will be in contact with the ice, right? And if the entire body is in contact with the ice, it's going to be very cold, right? So it does not do that. Instead, it stands on two legs most of the time. Okay, next. Keywords, right? Please write down keywords. Next. Keywords only. Okay, next we have two diagrams, two examples of renewable sources of energy. Remember we talked about this before. What is one advantage and one disadvantage of using renewable sources of energy? Let's have Gareth. Alright, can you tell us one advantage and one disadvantage?
Energy will be conserved and is reused.
Yep.
And disadvantage is only works when some elements are present.
Yes, very good. Okay. Right, let me write it down over here. Advantage. Energy can be conserved. Okay, the disadvantage, of course, energy is only available. What do you say? Only available when? When some elements are certain elements are present. Right? Like for example, the solar panel. Does it give you electricity all the time?
No.
Only when there is sun. Light. Okay?
So at night you don't.
Yep. No electricity.
That one is like just light. Normal light.
Normal light can, but not powerful enough. Right? You need sun. Yeah, you need the sunlight. It has to be sunlight. Okay? Then how about the other one? You see this is a wind turbine, right?
It needs to be wind.
Yeah, if there's no wind, how? You blow. You right? Waste energy, right? End up you waste more energy, right? So no wind, you're not gonna get energy. Okay, next, the energy from the sun, huh? Then you need to have rain, you know. You need to have different water level.
You need to go up, down, up,
Yeah.
down, up, down.
Must have different water level,
If
right?
you go down, then transport it up again.
But if you let it go up, you're gonna need energy to transfer it. So you waste energy again, right? So not gonna work.
Let it go down, let the heat evaporate, and then go to the cloud.
That rain, yeah, natural process. Okay. So part B, the energy from the sun is collected during daytime. How can this energy be used at night? Eunice, let's say I want to use the energy at night. What should I do? Store it somewhere, right? Store it.
Yeah.
Storeroom.
Storeroom.
Where do we store electrical energy?
Oh,
Battery.
Battery.
storage room.
Batteries.
Oh,
Batteries. Okay? What storage room? Batteries. Okay,
yeah.
storage.
Yeah, but batteries are stored
batteries
in
in storage room.
Yeah. Okay, I'm not going to write that, okay? So you can just write it down.
Right, what?
Okay, why are we unable to build a windmill farm in Singapore? Yes.
Because it's not enough space.
The wind in Singapore
Mm,
is strong enough.
good. Both are correct answers, okay? First one, we don't have enough space because for you to build a windmill farm, you need a really big space, right? Then of course the other reason is because we don't have like really strong winds. You know, have you ever experienced like a typhoon here?
But the
Yes,
the
there
wind
is.
and my house is quite strong.
There's the wind, what's it called? No, really got
Tornado, have.
No, not tornado, but like the wind.
Oh,
Hailstorm.
Hailstorm not enough. Hailstorm
I
is
see-
just
I
ice.
see like
No,
I see the
and then got
window
the thing before.
No, we need tornadoes, you know. Like if you really want a lot of electrical energy, it has to be like huge winds.
I rather not have
Huge winds.
electricity that has tornado.
Yeah, correct. Okay, we can get the electricity by burning the coal, right? Okay, so I'm not gonna write that down. I think that's easy enough. Next one, we have a picture. So this man is participating in a sport called the pole vaulting. So he's gonna run and jump across this bar. Now, what is the main?
What if it doesn't make it and falls down and breaks it?
Well, they are trained. Okay. So say the main form of energy that the man possesses at point B. Point B. What type of energy do you think he possesses, Gareth, again?
Kinetic energy.
Very good. Okay, KE. Oh, using handwriting. KE. Done. Okay, next. How about point D? Jared?
Gravitational potential energy.
Yes. GPE. It's my finger writing. GPE. Right? Like kindergarten. Next. Okay, so the pole is made of material that's flexible. How this property helps the man to pole vault over the bar? It's a bit tricky. Jared, can you help us with this? Jared. You are Jared. Yeah. Flexible.
It's flexible so that the man can force himself above point B.
Yep. It's something to do with energy conversion. Flexible. So what?
The EPE will be converted.
Yeah, so-
means that then you launch the man
Yeah, as
over the
it is
over
flexible,
the what's it called?
the bar,
The bar.
the vault consists of or contains elastic potential energy, which can be converted to kinetic and gravity
Can you like contains EPE?
can, but not in the exam, right?
Yeah.
Gravitational potential energy to help the man cross the bar. Okay, you see my this font is quite big, but I don't think you will write so many lines in your actual. But this is
You
really
can write more small.
no, this is big, right? So that's why it's occupying such a big space.
It's still 4 lines.
Really? Okay. So you see now, what is the answer here? You have to say that it has this because it's elastic, right? So it has elastic potential. You convert to what? Kinetic and gravitational potential. So it can cross the bar. Right? Keywords here. Next. Okay, this is a favorite question. Have you seen this before? This type of question?
Oh, no.
I don't know, for some reason they
Yeah, I see that before.
yeah, for some reason
My school used to do the kind of experiment with too dangerous.
okay.
Because
Right, so-
sometimes the spiral caught fire and almost burned down the school.
Serious,
What it is?
yeah.
Only it's
Yeah.
what's going on.
Too much heat, huh?
Shooting up.
Yeah, do you know the official name for this thing?
So
No.
what's your name?
He's shooting up.
This is called the lovely thermometer.
No,
Lovely thermometer, right? So that's why there's a heart shape in the middle, right? So the more lovely, the lovelier a person, the more water will come out.
No, but it's like
Oh, so much love.
Yeah, so much love, right?
Who do you love?
Okay, come on, let's focus on this thing, okay?
Myself.
Now, what is supposed to happen here? What's supposed to happen here? You heat the
melting.
thing. What will happen to this spiral?
Sun.
Turn, spin. Okay, you will turn, start to
It's still
turn.
going,
spiral. So, what energy does a candle? Wait, listen carefully, okay? This question, this particular one, right? 80% students get wrong.
Huh?
One more time, look very easy, right? First
I
one.
don't know this question like exams.
80% of the students get it wrong. Wow, you need to start to erase it.
There's a question where 99% people get wrong.
80 80% get wrong. So we're gonna check first. Okay, I'm gonna check everybody's answer. Hey, go there.
okay.
Answer for this. What energy does a candle possess? Tell me the answer first. Okay, I'm gonna
Is
review.
it like waxing?
Waxing,
Like, no,
eh.
heat energy.
Heat energy. How is heat energy?
Heat energy, light energy.
Heat energy, light energy. Hello. Yeah. What's the answer?
Heat energy and light energy.
100% wrong. Everyone wrong. See? Everyone wrong.
Heat energy.
Wrong. I'm
Deep
gonna
temperature
reveal to
Chemical
you.
potential energy.
Yes.
It doesn't have heat.
Chemical potential energy. Why?
That's
Why? Why?
Wait, do you mean the candle or the flame?
Read carefully.
Oh, I thought you meant
Read carefully.
I thought you meant the flame.
No, read carefully. Yeah, you're all referring to the flame. They're asking you the candle.
I never touched the candle before.
You have to birthday candle
Yeah,
before?
Be careful with that, don't break the thing. Make all the blood
Fragile.
come out. All the blood come out.
Is it, what's inside? Food coloring water.
No, yeah, it's just coloring.
It smells like roses.
What does it?
It has a good smell.
Yeah, explain, okay? Okay, now look at this, right? So chemical potential energy, right? So almost everybody gets this wrong. Why? Because you all keep thinking candle hot, hot.
No, I thought you referred to the flame.
Alright, it's not referring to the candle, right? So the candle is
Okay,
wax.
underline.
When you're burning the candle, the chemical potential energy changes to heat and light energy. Okay, right? So how about the next part? Explain how the heat from the flame causes the spiral to spin. Now this part is the is a really lengthy part. Okay, we're gonna try the start end technique.
This is the last question.
Start
For energy.
end technique. Okay.
Yay, really cool. It's very convenient.
Okay, so at the start, what do we have? What's at the start? The heat, right? Heat from the flame. Now how about the end part?
Move. Spin.
Yeah, spin. The spiral spin. And there are a lot of stuff in between, even though it's one mark. Okay, there's actually a lot of stuff in between. First thing, when the heat, okay, what's going to happen to the...
Is it a difficult question?
Yeah, it's quite difficult.
Is it only worth 1 mark?
Yes, unfortunately. Okay, so first thing, the heat from the flame, what does it do?
Gain heat.
No,
Burn
burn what?
the spiral.
No, no, it didn't burn the spiral.
The spiral rocky.
Okay, where is the heat from the flame? Let me see here. What does the heat do to the air around here? The air, right? Oh, there. Here got fire, right? What happens to the air?
Fire.
It'll be hot.
Ah, right.
Heat, the air will be warm.
Yes, so air.
Gain heat.
Oh, be careful, right? That is very wrong. So the air.
Is it glass?
Yes.
Wow, glass. I thought they were plastic. Plastic is cheaper. Yeah, which one cheaper?
Okay, next. The air gain heat. Then what happens next?
What's that sound?
Air around the flame gain heat. Alright. Okay, each one give me one. So you said the air. Who said the air gain heat?
Me.
Okay, next one. Gareth. What do you think is the next thing that happens?
Can I answer first?
No. One by one. Gareth.
Hot air spins the spiral.
Yeah, haven't. No, we're going line by line.
I know.
You see, air.
Air expands.
Correct. Volume
Air expands
increase.
and pushes the
Wait. Write down first. So the air expands. What's next? So what if the air expands?
It pushes the spiral.
Oh, expand will push spiral. So fast. Expand then push the spiral.
It's more powerful.
No, what's next?
Um,
Air expands.
oh,
Spiral being pushed.
Ah, what did you say? Sorry, you said something?
didn't say anything.
You went like.
No.
Oh, Eunice, what do you think is the next thing that
Air
happens?
rises.
Alamak, you're giving all the answers. Air rises.
I could just guess the air rises part.
Okay, air expands. Then the air rises.
Everything starts with air.
Yeah, of course
The main point is air.
you have to go and rephrase, right?
Main point
Rephrase.
is air.
So the air rises, and then that's all, right? It will cause the spiral to spin. Okay, so you can look back at the diagram. This is exactly what's happening. There's a heat from the flame. The air around the flame gains heat. The air around the flame expands. It rises, and then as it's rising, moving, the movement
force.
the thing, cause the thing to spin. Okay, and this is something that you have to explain very carefully to the examiner, because if you don't do that, they will say,
Like, they're talking to the examiner.
yeah, it's
Just imagine
correct.
Just imagine examiner's an idiot. Then you're still like teaching the examiner like,
So what's that?
Next time you're gonna hear this again. Imagine.
So what's that?
What's what? This thing?
Yeah.
It's a microphone directed at Jared. So everything he said is like going in. You see?
Is it a recorder?
Jared said that the examiner is
Is it a camera?
no, it's not a camera. No, no, no.
hello.
There's no camera here. Okay, no camera. All right. So yeah. So we are done. Is that the last one for?
Guess the last one.
Yeah, that's the last one, right? For energy.
stop it.
Okay, so we're gonna stop here. Go for a mini break. Okay, go toilet 5 minutes only.
We'll go
Because
play.
we have a lot of things to cover.
Would you stop it?
Just 5 minutes break.
Would you
Okay.
stop it?
Yeah, 5 minutes break.
Would you stop it?
Wait.